Hello and good afternoon. I've been working on optimizing some elements in GSSquared, namely the video code, and more specifically than that, the code that generates lookup tables that are used to drive the video display logic. As you may know, if you've been following for a little while, uh, I borrowed some algorithms from an older emulator project called Open Emulator. Great project. And it used a lot of heavy duty math driven by GPU functionality. I wanted to support a broader range of machines and all three major platforms: Linux, Mac, and Windows, of course. So I simplified that code quite a bit and implemented essentially a port to standard C++ of the video logic. And this is basically what people have been seeing here for a little while with GSSquared. I It was taking a while to generate this lookup table. There's 500,000 entries. Generates 2 MB of data. Mike Neal, who actually did the lookup table um, in an awesome back and forth. He and I have been working on this stuff. Um, was um, taking about a half second, roughly, to generate the lookup table whenever GSSquared would start up. So I went in and started hacking away at it this weekend. Let's say it was actually about 430 milliseconds on my Mac Mini to generate the table. I now have that down to about 12 to 13 milliseconds. So it can generate lookup table lickety split. Doesn't pause for a little bit, when starting up. Uh, and then this was driven by Mike's attempt to use the code in some project he's working on, namely, I think the A2C DVI project. It has very tight memory constraints, and so he and I have been uh, having conversations about ways to get the lookup tables size down considerably. So I went in and I identified that I had made not mistakes exactly, but there were some pieces I had left out that were important to being able to shrink the lookup table size. So what you're seeing right now is actually a lookup table that's 1/4 the size. I take that back, 1/2 the size of the previous revisions of this code. And it is, as you can see, um, identical, right? I did a lot of comparisons. I ran slideshow software looking at um, lots and lots of high res images on both data models. And I mean, there are some very, very subtle, very, very minor differences. Uh, but nothing, I don't think anyone would ever notice or complain about and say, hey, this doesn't look good. So anyway, so by shrinking the lookup table size, now I can generate the lookup table in 2 milliseconds, which is well under a 60 frame per second frame rate would require. So now I can make adjustments to the lookup table in, call it real time. It's not really real time, right? But 2 milliseconds means you can generate it and change the video logic instantly as far as the user is concerned. So I put in some functionality that I had hard coded before to allow you to set the saturation and the hue. Now, these are often controls on the back of a old-timey monitor. Modern LCDs, you don't get to control this stuff. But here's an example. I'm going to change let's see, make sure I get the right key here. People have commented about the purple. The purple doesn't look like some of the other emulator purple. down here. And I think that ultimately came down to differences in saturation, right? Saturation is sort of how, hard to explain, but it's how, it's not brightness exactly, but it's how much of the color is kind of crammed up towards the, how much of the color range is crammed up towards the top of like the RGB um, values versus, you know, more spread out. So we can adjust the saturation now. And that is, I believe, this one. Yeah. So that purple looks a little bit different from that purple. And I'm just adjusting the saturation. Pretend I'm turning the knob on the back of the monitor. So this might more accurately represent some folks' memories of this stuff. And maybe different monitors, right? Were either tuned differently or just variation in the analog circuitry. So there's that. Actually, let me grab my thing here so I can see what I'm doing. All right, so we've got that. I put it back on the standard. You can also adjust the hue, right? So on a TV or an old NTSC monitor, there's going to be maybe a color knob. And so that is going to let you do this. I'm turning the hue, I'm turning the color knob, and look, I'm basically, it changes the phase relationship of the monitor a little bit. So I can make it, you know, I can actually go all the way around the NTSC color wheel here and completely change the way the colors are represented. And again, this is literally just like, you know, imagine a circle of color. We're just like changing the starting point of our little arrow or vector. Am I back to normal now? That's back to normal. Okay. So this gives you some cool capability to adjust how you want to represent your good old-timey software. One thing, if we take the saturation right down, you can see we're taking the color out, taking the color out. I can take all of the color out. I've now created, I basically turned the color off. Now this isn't monochrome, which is to say you see the pixels are still all blended together here. It's not, if I were to, well here I can do it here. This is the green screen representation of this display. You know, it's dot on, dot off, dot on, dot off, repeating pattern. This is still smudged together, but there's just no color in it. I don't know if there were any monitors that displayed gray this way. There might have been. If there were, let me know. Leave a comment. But there you go. We can also, you know, go the other way. We can make it more and more saturated, more and more extreme. Anyway, there you have it. Have fun. Oh, and please like and subscribe. If you just do the one and not the other, I'm going to think you're not really fully invested in this. See ya.